Next, we'll take a look at comparators, which is a Java mechanism that helps us sort the same data on different sort keys in different orders. And you're familiar with this. Your music library, maybe at one point you sort it by the artist's name. In this case, we're looking at the Bees. But in another situation, you might want to sort it by song names to look through it by song names. That's the same data using different sort keys. How do we arrange to do something as natural as this in our Java sorts? Now, we used before, in order to be able to implement sorts that can sort any type of data, we use Java's comparable interface. And the concept is that there's some natural ordering of the data that you'll want to use most of the time. That's what the comparable interface is all about. But there's a different interface called the Comparator interface, which is a way to help us sort using some alternate order or many different orders on the same data. And the comparator interface, again, just says that it's going to implement a method compare that compares two different keys of a given type, of the generic type. Again, it has to be a total order. And this is very familiar. For example, with strings, there's many different ways that we might want to sort strings. We might want to use the natural alphabetic order, or we might want to make it case insensitive, or maybe there's different languages that have different rules of the ordering. We're sorting strings, but we're implementing a different ordering, various different orderings on that same data. That's what the comparator interface is for. So the Java system sort will have a different method to implement comparators. And the idea is that you create a comparator object and then pass that as a second argument to Java's sort routine. And we can do the same thing for our sorts. The idea is we want to decouple the definition of the data type from the definition of what it means to compare two items of that type. With the natural order, we had to put the definition of compare to within the data type. With comparators, we can do that outside of the data type, even at some later time. Strings were defined as part of the Java system, but we can define our own ordering on strings with a comparator. So in our sort implementations, we can change them as shown in this example to support comparators. To support comparators in our sort implementations, we'll pass an array of objects instead of array of comparable, and then as a second argument, pass a comparator. Then the less method will take that comparator as an argument, and it's the one that actually invokes the method compare of two different keys. This is a straightforward modification to our sorts. And then exchange, of course, rather than doing comparable, has to use object. So with these straightforward changes, add the comparator as argument to the sort and to less, and make our array to be sorted array of objects. It's easy to convert any of our implementations to support comparators. To implement a comparator, you can use this code as a model. I won't go through it all in detail, just to point out that this implements two different comparators as nested classes. So, say for this fictional class student that's got two instance variables, name and section. And the first one, called by name, implements a comparator for students. And when you compare two students by name, it's going to use the string compare to method. If you're going to implement it, compare two students by section, then it'll return just the difference of the sections, which is minus if less, 0 if equal, and plus if greater. And this code is a straightforward way to implement comparators that you can use as a model if you need to be able to sort data on two different keys. So here's just an example of what happens if with those implemented comparators for that class student using the Java system sort. If you call arrays.sort with your array of students and you give it this by name comparator, it'll put them in order, alphabetical order by the name field. And if you give it the by section comparator, it'll put them in order by the second field. Very convenient for all kinds of data processing applications. And we came up with that before when we were talking about using a sort for the gram scan. We needed to have a comparison for points that orders them by the polar angle they make with a given point P. That's what we needed for the gram scan algorithm for the convex hull. Points are a defined data type for geometric objects, and so what we need is code that'll compute the polar angle and use that as the basis for comparison. There's an easy way to do this based on CCW that is described here in this text. Most of the time, all you need to do is do the CCW of the 2 points, but you do have to check whether one of the points is above P and the other one is below. But otherwise, usually it's a CCW call. And this code, which again I won't go through in detail, is an implementation of a comparator for 2D points. It implements the compare method that takes 2 points as argument, and with just a little bit of calculation, it's able to do the compare. So this code is the basis for applying the system sort method or any sort method for the gram scan for the complex hull that we did at the end of the last lecture. So that's the basis for the gram scan method for the complex hull that we used at the end of the last lecture.